Let's look at this question. In a class of 80 students, 50 students passed in maths and 40 students passed in science. Match the following. Minimum number of students who passed in both, maximum, okay. So we are looking at maximum and minimum. This count we are looking at, okay. So let's work. The best case would be when I have maximum number of people passing in both. And that would be given by this situation. Maths, science. 40 people passing in science and maths both, 10 people here. And because there were 80 students, 30 passing in neither. This is one extreme. The other extreme would be 10 people passing in both. You have 40 people passing in only maths and 30 people passing in only science and 0 people failing in both. So now, based on these two extreme situations, we have to simply answer. Minimum number of students who passed in both has to be 10. Okay. Maximum number of students who passed in both, 40. So it has to be here. Minimum number of students who failed in both is 0. So option A. Maximum number of students who failed in both has to be 30. Minimum number of students who pass in at least one. At least one would be minimized here when you have just 50 people passing in at least one subject. Maximum number of students who passed in at least one would be this case when you have everybody passing in at least one. So this would be the final answer. This is of course not a CAT variation, but a good basic fundamental check. In a class, a student has an option not to participate in sports or not to participate in cultural activities. However, a student cannot opt for participating in sports, for not participating in sports and nor in cultural activities. So everybody has to pick at least one. Okay, so 20 students in the class have opted out of participating in sports and 10 students have opted out of participating in cultural activities. Okay, why is my pen not working? No, it is back. So 20, oops, this is a different slide. In a class, so 20 students have opted out of participating in sports. So if you have opted out of participating in sports, can I say you have decided you will definitely participate only in cultural activities? Similarly, 10 students have opted out of participating in cultural activities. So you're definitely participating only in sports now. If 15 people participate in both sports and cultural activities, find the number of students in class. 10 plus 20 plus 15 adds up to 45. Now, linguistically, language-wise, you can always have a different way of recording this. Those who leave sports, those who leave those who leave sports, those who leave cultural activities. Can you see? You cannot leave both. So this is definitely 0. People who have left sports is 20. People who have left cultural activities is 10. And people who are pursuing both activities are 15. In this case, also the same value of 45 you would reach, but representation wise, it is going to be slightly different. Next one. A B school has to form an academic committee of 4 members. The members have to be selected out of 5 teaching staff, 3 non-teaching staff, and 4 students. If the committee is formed by randomly choosing any 4 persons, what is the probability that the committee has exactly 2 students? So if I'm choosing randomly 4 people, that can be done in 12C 4 ways. But I have to ensure exactly 2 students are chosen. So 4C2, 2 students out of 4. And from 8 non-students, I select the other 2. So this will turn to 6 into 28 by, now see 4C2 and 8C2 are fairly simple to remember. This I don't remember. So I will break this down. 12 into 11 into 10 into 9 into 24. So cancel, cancel. I get 2. Okay. Cancel and cancel. I get 3. I get 5. 6 is gone entirely. So I'm left with 28 into 2, 56 by 11 into 15, 165. So answer should be option C. Next, in the world school, a student has the option to leave out math or science as a subject, but he cannot leave both. After 50 students dropped math and 30 dropped science, there were 20 students who opted studying both the subjects. Find the strength of the class. If you go back, question 2 is precisely a replica of this, or this is a replica of question 2, whichever order you want to understand it in. You can happily make a Venn diagram, math, science, 50, 30, 20, strength of the class, 100. This question doesn't deserve explanation. It is exactly the same as the second one. Okay. The digits in a 5-digit number are such that they are alternately even and odd, with unit digit being even. If no digit appears more than once in the number, how many such numbers are possible? Okay. So a 5-digit number where the digits are alternately odd or even, and the unit digit is even. This is even, so this has to be odd, this has to be even, this has to be odd, this has to be even. Now the biggest challenge here, or the only thing that we have to ensure, is that the leading digit doesn't become 0. So how many ways of filling up the leading digit? 4 ways, either 2 or 4 or 6 or 8. Now odd digits, none have been used so far. So how many ways of filling it up? 5 ways. Now even digit in the third spot can be filled up in 4 ways again. Whichever digit has been used up here, apart from that, all other even digits are okay along with 0. So you will have 4 ways here. You will have another 4 ways here. And finally, you will have 3 digits to choose from in the units place. So altogether, we get how much? 64 into 15. So the final answer here has to be 960. That will be all for this modern maths bites. Hopefully you learned something. Okay, bye.